So let me show you how to solve a multiplication problem using the traditional algorithm. The first thing you need to think about is how to set up a problem using the traditional algorithm. You might be given a problem that looks like this: 36 times 54 going across. This is not a helpful form for the traditional algorithm at all. For the traditional algorithm, they need to be stacked on top of each other. So if you're given a problem that looks like this, you're going to want to, number one, rewrite the problem like this. And I could have put the 54 on top. I will get the same exact answer either way. Now that I have the problem set up, I can actually start multiplying. I'm going to start multiplying in this lower right-hand corner right here at the 4. First, I'm going to multiply the 4 by 6. I'm always starting at the lowest place value and making my way toward the highest place value. So 4 times 6 equals 24, so I put my 4 down here. The 2 for the 20, I need to carry, just like I would do in an addition problem. And I'm going to put that up here by the 3, so I don't forget about it for later. Next, I'm going to multiply the 4 by the 3. Again, I'm starting with the lowest place value, the 1s, and moving to the next highest place value, which in this case is the 10s. And I am going to multiply 4 times 3. Now here's an important thing to remember. This isn't really a 3, it's a 30. You have to remember the place value. But because of the way the traditional algorithm is set up, I'm treating it as a 3. The place value has already been accounted for by its place in the answer here. This is a tens answer. But just so you understand, this isn't really a 3, it is a 30. So I multiply 4 times 3 and I get 12. But I can't forget about this too. I need to add that to 12 and I get 14. So I drop the 4 right here. Now if I had another number in the hundreds place, I could carry the 1 of 14 one more place. But I don't, so I drop it right here next to the 4. So I finished multiplying the 4, but I still have the 5. And remember, the 5 is actually a 50. So I need to make sure that I start in the tens place. That's here. Because I can't multiply anything by 50 and get an answer in the ones place. It's just not going to happen. Some people like to put a 0 right here so they remember that they can't possibly have an answer in the ones place when they're multiplying by a number in the tens place value wise. So I'm going to multiply 5 times 6. Got a little bit of erase when I was erasing my 4 arrows. 5 times 6 is 30. So I'm going to put a 0 right here, and I'm going to carry my 3 next to the 3. Now I'm going to multiply 5 times 3, and remember this is really 50 times 30, but because I've got my place value set up in my answer, I don't have to worry about that at this point the way I do when I'm doing partial products. So 5 times 3 is 15, but I've got to add the 3, and that makes it 18. So I put my 8 right here. There's no other number to carry the 1 to, so I'm going to put it over here. So I'm not quite done yet. I have all of my numbers, but I need to put them together by adding. So I'm going to rewrite this on a fresh page. You have paper that probably goes down farther than this, so you can just keep working down. Or if you run out of space, feel free to recopy as I am doing right now. And I'm just rewriting all the numbers I had on the other page. Let's check and make sure that I copied it right. Yep, looks great. And so now I'm going to add them together to see what my total answer will be. This is similar to partial products, but I didn't have to make sure I had the numbers in the right place value place because the traditional algorithm takes care of that for you. So I'm just going to add them up from right to left, and I get 1,944. So our original problem was 36 times 54, And my final answer was 1,944. Let's try another number, or another problem with some other numbers. Let's say I have 18 times 37. Again, I'm going to get a fresh page to give myself lots of room. This time I am going to put the 37 on top. No reason, just felt like it. And I'm multiplying. Again, I'm going to start down in this corner with the 8. I'm going to say 8 times 7, and I'll write my work over here so that it might be easier to follow this time. 8 times 7 equals 56. So that looks like an X. So I drop the 6 down here and carry the 5 up here. Now I do 8 times 3 equals 24, but I have to add the 5, so I get 29. Nowhere to carry the 2, so I drop it right here. Now I'm going to multiply the 1. 1 times 7 equals 7. Remember, I'm going to put it in the tens place because this 1 isn't really a 1, it's a 10. And 10 times 7 is 70. I can put my 0 here, so I remember that, or I could leave it blank. Some people also go ahead and put the 0 before they do any other math so that they don't forget and put the 7 in the wrong spot accidentally. Now I'm going to do 1 times 3 equals 3, and I'm going to put it here. Notice that my place value is already being taken care of for me because this isn't really 1 times 3, it's 10 times 30. And 10 times 30 equals 300. And look where my 3 is here. It's in the 300s place. So that's the really convenient thing about the traditional algorithm. You don't have to keep track of place value. The setup does it for you. But don't forget that that's why it's happening, because I see a lot of students make mistakes that could be fixed easily if they were thinking about their place value. Always be thinking about what makes sense while you're working on these problems. And if something doesn't make sense, there's probably a mistake somewhere and you should go back and look for it. Now this time I do have room, so I'm just going to do my addition right underneath the problem. 6 plus 0 equals 6. 9 plus 7 equals 16. I'm going to carry that 1, just like I carried the 5. And then 1 plus 2 equals 3 plus 6. 3 equals 6. And I get the answer, 666. Let's try another one. Let's try 42 times 93. Okay? First thing I'm going to do is rewrite the problem. Having the 42 on top. Again, it would be equally correct to have the 93 on top. I'm going to start down here in the corner with the 3, and I'm going to do 3 times 2. It's kind of nice to work out your problems to the side, especially for your teacher. So if you did just make a mistake, like let's say that I had put 3 times 2 and wasn't paying attention and put 7, my teacher's going to know exactly why I got the wrong answer and hopefully not take off as many points because it was just a silly little mistake. I knew how to do the problem. But those mistakes are hard to find if you don't show your teacher your work, and then you're going to miss all the points. So 3 times 2 equals 6. I have nothing to carry. Now I'm going to do 3 times 4, and that equals 12. I'm going to put the 2 down here. I've got nowhere to carry that 1, so I'm going to drop that as well. Now I'm going to start with the 9. 9 times 2 equals 18. I'm going to put the 8 right here. I'm going to put my 0 because I know that it's actually 90 times 2, which equals 180. And I'm going to carry the 1 up here by the 4. Now I'm going to do 9 times 4. And that equals 36, but I have to add my 1. That equals 37. Put the 7. I have nowhere to carry the 3, so I'm going to drop that right here. Now I'm ready to add. 6 plus 0 equals 6. 2 plus 8 equals 10. 0, carry the 1. 1 plus 1 equals 2, plus 7 equals 9. And 3 plus nothing equals 3. So my answer is 3,906. If this doesn't make sense to you, go ahead and watch the video again, or you can talk to your teacher or another student for help. If it is making sense to you, please move forward in the video and try it on your own. So now we're going to take a crack at multiplying 3 and 4-digit numbers using the traditional algorithm. We're going to follow the same steps as we did with 2-digit multiplication. We're just going to do it one more time or 2 more times as we need to based on how many numbers are in each number we're multiplying. So let's say that I have 342 times 16. I'm going to stack this so that my ones line up, my tens line up, and my hundreds line up. I like to put the biggest number on the top. You of course don't have to do this, but for me it's easier to multiply when it's stacked this way. The one thing you have to make sure of is that your ones are lined up and your tens are lined up, and then the rest of the numbers will be lined up as well. So I'm going to start out in the bottom right hand corner with 6 like I did with 2-digit multiplication. And I have 6 times 2, and that equals 12. I'm going to put my 2 down here and carry the 1 up by the 4. Now I have 6 times 4, and that equals 24. But I have to add that 1 that I carried, so I end up with 25. I put the 5 down here. I carry the 2 up next to the 3. Now I have 6 times 3. That equals 18, but I can't forget about my 2. I have to add that, so I end up with 20. Now I can multiply by the 1. I'm going to put the 0 right here so I don't accidentally put my answer in the ones place, which would make no sense because 10 times anything is not going to have an answer in the ones place. I have 1 times 2 equals 2. Now I have 1 times 4 equals 4. And 1 times 3 equals 3. I can add them together now. 2 plus 0 equals 2. 5 plus 2 equals 7. 0 plus 4 equals 4. And 2 plus 3 equals 5. So my answer is 5,472. Let's try it with 2 3-digit numbers now. Let's say that I have 187 times 249. I'm going to stack them up so the ones line up, the tens line up, and the hundreds line up. Since both of these are 3-digit numbers, it doesn't really matter to me which one is on the top. So I'll go with 249 on the top. I'm going to start down here in the lower right-hand corner. 7 times 9 equals 63. 4 times 7 equals 28, but I have to add that 6 to it, so I get 34. I'm going to carry the 3 up here. 7 times 2 equals 14. I have to add the 3 and I get 17. Now I'm ready to move on to the 8. 8 times 9, notice that the 8 starts over here at the 9. 8 times 9 equals 72. I'm going to drop the 2 right here, keep my 0 so that I have everything lined up in the correct place. Carry the 7 over the 4. It's getting very squished. Now I have 8 times 4 equals 32, but I have to add that 7 and I end up with 39. I'm going to carry the 3 over the 2. Now I'm doing 8 times 2 equals 16, plus the 3 equals 19. Put my 9 right there, nowhere to carry the 1, so I drop that 2. Now I'm doing the ones. This is our first time doing a 3-digit number times a 3-digit number, so we're going to have 3 rows down here instead of just 2. This 1 is actually a 100, so I won't have any answers in the ones place. I also won't have any answers in the tens place. I'm going to start here at the hundreds place. So 1 times 9 equals 9. And put that right here because it's actually 900. Then I have 1 times 4 equals 4. And 1 times 2 equals 2. Now, just as before, I'm going to add them all together. So 7 plus 9 is 16, plus 9 more is 25. Carry the 2. 2 plus 1 is 3, plus 9 is 12, plus 4 is 16. Carry the 1, and 4. So my answer is 46,563. That's quite a big number, which you're going to get when you have 3 digits times 3 digits. Let's try one more. What happens when I have a 4-digit number? If you guessed the same exact thing as before, you would be exactly right. 3. So 5,632 times 213. I'm going to try to write a little bit smaller so I can hopefully fit it all on one page, but if I can't, that's okay. I'll just copy what I need to and keep going. So I'm going to stack it up so that the ones are aligned, the tens are aligned, the hundreds are aligned. Everything should be aligned. And now I can start multiplying. I'm going to start out down here in the lower right hand corner. 3 times 2 equals 6. 3 times 3 equals 9. That's kind of a crazy looking 9. Let me erase that. There we go. 3 times 6 equals 18. I'm going to drop the 8, carry the 1. 3 times 5 equals 15. I have to add that 1, and I get 16. Whew, I'm done with the 3s. That was a lot of multiplying. I'm going to go ahead and erase this. Don't erase your work so your teacher can see it. I'm going to erase it so that I can keep working on this page, but still show you all my multiplication work. Now I'm going to move on to the 1. 1 times 2 equals 2. Oh, I have to remember to put my 0 here because this 1 is actually a 10. 1 times 3 equals 3. 1 times 6 equals 6. And 1 times 5 equals 5. Done with the 1. Now I can move on to the 2. Again, I'm going to erase this work over here. 2 times 2 equals 4. But is this really a 4? No, it's 200 times 2, which equals 400. So I'm going to put a 0 in the ones, a 0 in the tens, and now I can put my 4 in the correct place value spot of 400. Now I'm going to do 2 times 3, which equals 6. 2 times 6, which equals 12. I'll put the 2 right here and carry the 1 over there. 2 times 5 equals 10, but I have to add my 1, so it's actually 11. And now I'm ready to add all these numbers up. 12, 16, 16, 22, 28. 2 plus 1 is 3, plus 5 is 8, plus 2 is 10. Oh my. I have to put in my commas now. 1, 2, 3, comma, 1, 2, 3. 1,208,616. It's quite a big number, but that's what you're going to get when you're multiplying 4-digit and 3-digit numbers. So now it's time for you to take a crack at it. Proceed on with the video if you feel like you're ready and try them on your own. If you don't, you can watch this video again, or you can get help from your teacher or another student.